Humanity has had its eyes on Jupiter for centuries. First, telescopes, and in recent decades, 8 deep space probes were used to examine the largest planet in the solar system. NASA is returning to the gas giant with a large spacecraft called Juno. Equipped with unique sensors, Juno will look deeper into the planet's structure than ever before to find out the answers to basic questions about Jupiter's makeup and how it formed.
Juno's looking for how Jupiter formed and really how planets are made in general. We're very much looking for the recipe for planets. The special thing about Juno is we're really looking at one of the first steps, the earliest time in our solar system's history. Right after the sun formed, what happened that allowed the planets to form, and why are the planets slightly different composition than the sun?
Jupiter is so far away from Earth that even when it's at its closest to us, it will still take a radio signal moving at the speed of light about 34 minutes to cross the distance. Getting Juno on a course to reach the distant planet is the job of an Atlas V rocket, one of the largest in NASA's catalog. It has already been used to loft several NASA missions for the Launch Services Program, including the New Horizons spacecraft on its way to Pluto.
It's flown quite successfully, like I said, the 28 times. Pretty challenging missions, pretty challenging payloads. It's got a heritage that goes back to the Atlas I and some of the components and in the upper stage. So it's an evolution of a family. And in its current configuration and shape and form, I'd say it's pretty robust.
The alignment of Earth and Jupiter leaves the mission's managers with a limited window to launch the spacecraft.
Juno only has a 22-day launch window, or unless we're down for another 13 months until our next opportunity. So it's those kind of challenges with making sure you do all the little things necessary to maximize the opportunities that you get for those 22 days.
Even riding a powerful rocket into space will not be enough on its own to push Juno to its target. The spacecraft still needs the kind of assist only a planet can provide. That's why Juno will go into an orbit that will bring it past Earth 2 years after launch and use the Earth's gravity to slingshot it out to Jupiter, arriving there in August 2016. Aside from distance, Jupiter offers unique challenges to a spacecraft, such as a radiation field rivaled in intensity only by the sun.
We have a box in the middle of the spacecraft that we call a vault, and it's made out of titanium, and that shields all the electronics from these hazardous radiation. And we're very much an armored tank going to Jupiter.
Just as Juno is building on the knowledge gained with past missions to Jupiter, future missions will build on Juno's findings.
If we could start to understand the role that Jupiter played in how the planet formed and how that eventually governed the creation of the other planets and Earth and maybe even life itself, then we know a little bit about how to look for other Earth-like planets maybe orbiting other stars and how common those might be and the roles that those giant planets that we see orbiting the other stars play.
NASA's Launch Services Program has dispatched several probes to deep space in recent years, including the Opportunity and Spirit rovers on Mars, the Cassini spacecraft that is studying Saturn, and the New Horizons mission that is on its way to Pluto. The schedule does not lighten for the LSP team after Juno. Along with an experimental polar orbiting weather satellite, missions to the Moon and Mars are set for launch this year.
Really, all these missions that LSP is involved in and NASA is involved in are all precursors to the bigger picture of getting humans out beyond low Earth orbit to Mars, to an asteroid and beyond.
For now, though, the team is focused on getting Juno safely on its way to Jupiter.
I will be celebrating when I hear that spacecraft has separated successfully and those solar rays are out.